Okay, section K is not in the book. This is an added section that I'm adding to this book. I will list the homework for you in under files in Canvas. I will talk about that in our first class meeting. So section K talks about a right triangle trigonometry. This is from geometric point of view. From geometry, we know that a triangle with one right meaning 90-degree angle, is called a right triangle, and a right angle is denoted by the following. So if you don't see that symbol, you can't assume it's a 90-degree. And what's so special about a right triangle is that one angle is 90 and the other two angles are called acute. Acute angles are angles that are between 0 and 90 degrees. They can't be 90 degrees and they can't be 0. Bigger than 0 and smaller than 90 degrees. I just realized. There we go. And an obtuse angle is an angle that's bigger than 90 degrees. Geometry is built on acute angles. Trigonometry is built on acute and obtuse angles. So in this section, we will see how this plays. We're going to assume that we're talking about a right triangle, which means the other two angles are acute. So in any triangle, if you take the side opposite of 90, that's always labeled as the hypotenuse. If you move and label an angle, you pick any angle you like. Let's say you pick this angle to be angle theta. The side opposite of that angle we label as the opposite side, meaning it's the opposite side of the angle. And the remaining side, the side that's left over, is labeled as the adjacent. If I label these sides x, y, and z, then I know from Pythagorean theorem that h squared equals z squared, which is the hypotenuse squared, equals x squared plus y squared. Something to keep in mind. Now, associated with every right triangle are 6 trigonometric functions, and they are really emphasized in SOHCAHTOA. Make sure you spell that correctly. If I take the sine function, the sine of this theta would be the opposite over the hypotenuse. The cosine of this angle theta is the adjacent side divided by the hypotenuse. So this is a ratio, and the tangent of theta is the opposite side divided by the adjacent side. Something that you need to memorize. And associated with those three are the cofunctions. That is, associated with sine, cosecant of theta is the reciprocal. It's really the hypotenuse divided by the opposite. Associated with cosine is the secant of theta, and that is the hypotenuse divided by the adjacent. And associated with tangent is the cotangent of theta, and that is the adjacent divided by the opposite. So this 6 trigonometric functions you need to memorize and get out of the way. That's always the case. Also, if I label this angle beta, let me go with a different color. What color should I choose? Let's go with if I label this angle beta, as far as beta is concerned, this would be the opposite of beta, this would be the adjacent of beta, and the hypotenuse is fixed. What I notice is that if I take beta, add to it theta, plus 90 degrees, the sum of three angles in any triangle is 180 degrees. So beta plus theta equals 90 degrees. What we call this complementary angles, indicating that beta is 90 degrees minus theta, or theta is 90 degrees minus beta. So that's important, and I'm going to elaborate on that later on in the section. So we start with a very basic problem, number 12. It says, find the value of the six trigonometric functions of the angle theta. There's theta. As far as theta is concerned, this is the opposite, this is the adjacent, and this is the hypotenuse. And I know from Pythagorean that the hypotenuse squared equals the adjacent squared plus the opposite squared. 8 squared equals 16 plus 9, which is 25. And if I square with both sides, I will get the hypotenuse to be, it should be plus or minus 5. In geometry, length cannot be negative, so I label this side as 5, and then I could find the sixth trigonometric function, that is the sine of theta, cosine of theta, tan of theta. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. And of course, cosecant of theta would be 5 over 3. Secant of theta equals 5 over 4. And the cotangent of theta would be the 4 over 3. Now, I'm going to add to the homework to find the angle. If you'd like to find the angle, if the sine of theta equals 3/5, theta would equal the inverse sine of 3/5. Some books call that also the arc sine 3/5. And if I plug this in my calculator, I could figure out what that angle is. And let me get that calculator out. That's the one I wanted, yes. And make sure I am in degree mode. And if I take, you notice there's sine, cosine, tangent, and on top of those, there's inverse sine, inverse cosine, inverse tangent. If I take the inverse sine of 3 divided by 5, I will get 36.86, let's say 36.9 degrees. So that is 36.9 degrees. If I decided not to use the sine, if I decided to use the cosine, well, it doesn't matter. Theta in this case would be the inverse cosine, or the arc cosine of 3/5. And if I took my calculator out again and said, let's use an inverse cosine instead of 3 divided by 5, guess what I'll get? Oops, I messed up. That should have been a 4, right? My mistake. So if I go by the inverse cosine of 4 divided by 5, I'll notice that I'll get the same angle, 36.869, which is 36.9 degrees. And if you decided to use the tangent, it really makes no difference. That would be the inverse tangent or arc tangent of 3/4. So I'm showing you this so you are certain that you can't get the problem wrong. In case you're wondering which of those three should I use, any one of them will do. And you notice it's the same answer regardless. And once I know one angle, I know how to find the remaining angle, right? If I know this angle here is 36.9 degrees, I can find this angle by taking 90 minus that, or I could use the trig. It doesn't matter. So on the homework, I'm going to add to the homework that you find the angle in each triangle, right? The angle given. I'd like to look at another problem. Problem number 18, same deal. It says, find the six trigonometric functions, that is the sine, cosine, tangent, secant, cosecant, cotangent. So, first I need to figure out the angle is not on this side. The angle is really here. This is the opposite. This is the adjacent. And if I want to find the hypotenuse, I would use Pythagorean identity. That is, I would say the hypotenuse squared is radical 3 squared plus a 2 squared. I don't like that 3. Let me fix that. The hypotenuse squared is 3 plus 4, which is 7. And h should be plus or minus the square root of 7, except in geometry length cannot be negative. And in case you're wondering why I'm saying that, in trig, length could be negative. And now that I have all three sides, it's fairly straightforward. The sine of theta is the opposite over the hypotenuse, 2 over radical 7. And if you rationalize, that's 2 radical 7 over 7. The cosine of theta is the adjacent over the hypotenuse, radical 3 over radical 7. And if you rationalize, meaning if you multiply by radical 7 top and bottom, that's the square root of 21 divided by 7. And the tangent of theta is the opposite, which is a 2 over the adjacent, which is radical 3. And if you rationalize, you get 2 radical 3 over 3. And if I find the cosecant of theta, that's simply the reciprocal, radical 7 over 2. You could use the triangle for that as well. Secant of theta is the reciprocal, which is radical 7 over radical 3. If you rationalize, that's square root of 20, no, that's the square root of 21 over 3. And if I take the cotangent of theta, that is simply the reciprocal, which is radical 3 over 2. And if I was to ask you to find the angle, you could find the angle by picking any one of those. The reason we don't use those three, because they're not in the calculator. So if I get my calculator and pick any of those, let's say I pick cosine. And you could go by the rationalized or non-rationalized. It makes no difference. So if I take the inverse cosine, and if I go by the square root of 3 divided by the square root of 7, that angle is 49.1 degrees. So I could say theta equals the inverse cosine of, what did we say, radical 3 over radical 7, or square root of 21 over 7. And theta would be, what was it again? 49.1 degrees. 49.1 degrees. That sort of zero power indicate that this is degrees. There are three measuring of angles: degrees, radians. Gradient we're not going to use. We're going to stick just with those two. Now, if I take a right triangle, I'm going to derive a few things. If I take a right triangle and I label that angle theta, this side right here would be the opposite, this side here would be the adjacent, and this side right here would be the hypotenuse. If I look at the sine of theta, that is the opposite over the adjacent. The cosine of theta is, okay, you forgive me, right? We forgive each other. Adjacent over hypotenuse, and the tan of theta, so make sure you get those memorized, the opposite over the adjacent. I noticed that if I take 1 over the opposite over the hypotenuse, that's 1 over a fraction is the reciprocal of the fraction, and that would be the cosecant of theta. And if I look at this closely, I'll say, wait a minute, but that means, that indicates that this is 1 over the opposite over the hypotenuse is the sine of theta. So 1 over the sine of theta is the cosecant of theta, and similarly, the sine of theta is 1 over cosecant of theta. Those are called reciprocal. These are the reciprocal identities. And if I take 1 divided by cosine of theta, that is 1 divided by the adjacent over the hypotenuse. 1 over a fraction is the reciprocal of the fraction, but that's the secant of theta. And similarly, the cosine of theta is 1 over the secant of theta. And if I take 1 divided by tangent of theta, that is 1 divided by the opposite over the adjacent. That's the adjacent over the opposite, which is the cotan of theta. And similarly, the tan of theta is 1 over the cotan of theta. Also, I noticed that if I take the tangent of theta and use the triangle, tangent of theta would be, let me go the other way around, it's easier. If I take the sine of theta, minus sine of theta, divided by cosine of theta, sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse. Those cancel out when you multiply by the reciprocal. That's the opposite over the adjacent, which is the definition of tangent. So tangent has another identity, and similarly, the cotan of theta is the reciprocal of those two, which is the cosine of theta over sine of theta. Now, I'm going to derive 3 more before I conclude this video and move on to the next video. So, if I take the hypotenuse squared, again from this triangle, if I take the hypotenuse squared, that is the opposite squared plus the adjacent squared. If I decided to divide this side by the hypotenuse squared, this side by the hypotenuse squared, and this side by the hypotenuse squared, I'll get 1 equal. Using algebra, I could reverse the distributive of power, and 1 will equal sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. And this would be my first Pythagorean identity. The sine squared of theta plus cosine squared of theta equals a 1. If I divide this by sine squared of theta, sine squared over sine squared is a 1. Cosine over sine is the cotangent, it's right there. And 1 over sine, we agreed, was the cosecant squared of theta. Because I'm dividing by sine squared. Sort of like saying sine squared of theta plus cosine squared of theta equal 1. Divide by sine squared each of those, assuming that the sine does not equal 0. That's a 1. This is the cosine of theta over sine of theta squared. And this is 1 over the sine of theta squared. Cosine over sine is the cotangent of theta squared. And 1 over sine is the cosecant of theta squared. If I go back to this and I divide by cosine squared of theta, I'll get the third Pythagorean identity. Sine over cosine is the tangent squared of theta. Cosine squared over cosine squared is 1. 1 over cosine squared is the secant squared of theta. So those identities are a must. Now I'm going to stop this video here and continue this section in the next video.